units, dimensions and errors. Dear students, before going into the topic, we must understand that physics is the study of nature and its laws. Now, the description of the laws of nature involves the measurements of different physical quantities. Again, to measure a physical quantity, we need some standard. The standards are called units. Now, we have large number of physical quantities like length, area, temperature, mass, etc. However, not all the physical quantities are independent. For example, if you know the length of a square, you can calculate the area of a square. So, the area can be derived from the length of a square. So, we have two categories of physical quantities: the fundamental physical quantities and derived physical quantities. Now, it turns out that the number of fundamental quantities are 7. Now, we have different system of units, and in each system of units, the number of physical fundamental quantities are 7. The most popular system of units is SI units. In SI units, the fundamental quantities are length, mass, time, electric current, temperature, amount of substance and luminous intensity. The unit of length in SI system is meter. The unit of mass in SI system is kilogram. The unit of time is second. The unit of electric current is ampere. The unit of temperature is Kelvin, and unit of the amount of substance is mole, and the unit of luminous intensity is candela. Dimensions. We have seen that there are two kinds of physical quantities: the derived physical quantity and fundamental physical quantities. Now, all the derived physical quantities can be expressed in terms of fundamental physical quantities. So, in a way, all the physical quantities can be written or can be expressed in terms of fundamental quantities. Now, physical quantities can be written as a product of different powers of the base quantities. The exponent of the base quantity that enters into the expression is called the dimension of the quantity in that base. Let's explain it with an example. Let's take the example of acceleration. Acceleration is defined as rate of change of velocity. So, it can be written as velocity by time. Again, velocity is rate of change of displacement. So, we can write it length by time. So, we have this kind of expression. Now, we have a standard notation for fundamental quantities. We have seen that length and time are fundamental quantities. What we have done is we have expressed acceleration in terms of fundamental quantities length and time. In terms of rotation, in terms of notation, length, sorry. In terms of notation, acceleration can be written like this, that is Lt minus 2. It is written like this, Lt minus 2. So the dimension of acceleration in length is 1, or it is read as dimension of acceleration is 1 in length and minus 2 in time. Now we have some important applications of dimension. First of all, the concept of dimensions is helpful in checking the validity of equation. To understand this concept, let's take the example of this equation, the familiar one, x equal to ut plus half at square. Now here we must understand that we can add or subtract only singular quantities. You cannot add length with time. While checking the validity of equation, we make use of this concept. Now let's come to the given example. In the given equation, we have three terms, that is x, ut and half at square. Now the equation can be valid only if the dimension of three terms are same. Now in this case, dimension of x is L. Now the dimension of ut is Lt minus 1 into t, that is again L.